Yeah, absolutely. Absolutely, because remember when we have common external tangents? Those two segments would have been the same. And that's where this comes from.
Oh, true.
If I go to the other one, I can do the same idea here. And go between them. Yep. Actually kind of drawn this not too badly today. So that one you could get 4 of them. Okay? That way you could get 4 of them. What about the last one?
Can I do it?
What's that?
Can I do it?
Sure.
Got it.
What? Oh, just shoot. Because the one in the middle wouldn't work. So how many ways were you able to get a common tangent for that?
Uno.
Just one. Now, the question you guys had in the homework was one where it was, I think this,
That was up.
yeah, it was a circle in a circle, wasn't it?
Yeah.
Can that have a common tangent? Tangent.
Yeah.
No, it can't. Okay. Quick question then. How many? All right, hold on. If you take 3 chords in a circle, how many sections can you create? Think about it. Take a second to see if you can figure that out. Remember, how many, if you take 3 chords in a circle, how many sections can you create on the inside of the circle? There's an actual definable answer to this. See if you can draw that real quick and think your way through it. I don't know. I don't remember.
3 chords in a circle.
All right, so you guys are saying.
That's not equal to each other.
All right, so some of you guys said 4. I heard 4 a lot.
7.
Okay. Well, what if you did this?
Oh, I keep drawing. Stories.
That's how many?
6.
That's 6, isn't it?
6. I got it right.
You said 7. How do you get 7? Now how many is that? Yeah.
Wow. The answer is actually 7. The maximum weight. Go. The answer is actually 7. If you take 3 chords, usually what people do, and the 4, I've never heard someone just jump out and yell 4 and say, yeah, it's got to be 4, it's got to be 4. Is you're just thinking of slicing them out. You know, usually what people do is they take the circle and they just make they do that. Because in your mind, you're thinking sections. You're thinking, oh, I'm going to slice it into even parts for to pass out pieces of pie or whatever. That's usually what people do.
No.
But honestly, this is what you can do, so you can slide it over.
That's how I come.
The maximum win would be 7 of them. Now, that's an actual ACT question.
Gross. Just like that.
Yeah. It's worded a little bit differently, but it's for the most part, it's.
No, I was saying that's how I come by.
Because that's what you think of. Because you automatically think to splice it, make the X, and put it in the middle, and cut it into
Yes.
even parts. Okay? All right. So the other part that happens a lot of times, when she gets back, tell her the answer was 8, and see if she can figure it out.
No, I'm
Which
just gonna
means
do
you
it
can get
kilos
into
the
stuff
answer.
like this.
Or she just won't care.
When you have, remember yesterday we talked about that whole idea of that point of tangency. If, excuse me, this is our tangent segment to a circle, which means it is perpendicular to a radius. Now, when you have a tangent segment and a perpendicular segment, well, it creates a
Segment.
right angle, which then creates a hypotenuse.
Which then you use SOHCAHTOA.
Am I using SOHCAHTOA here, or am I going to use Pythagorean theorem?
Pythagorean theorem.
Excuse me, I'm just using Pythagorean theorem because I'm not asking for the angles. If I was asking for an angle, yes, I would definitely use SOHCAHTOA, and we will do that eventually. But not even remotely close to today.
Don't let her.
Don't do it. Oh, yeah.
I was nice. The answer was 8.
What did you think it was, Michaela?
You were halfway there.
Because it was 8. Oh wait, no, it was 7. Now you're thinking no. No, it wasn't.
It was
No.
7.
Yeah, see?
We tried to play a joke on you. The answer really was 7.
I'm so confused right now. What was the real answer?
7.
7. Most people would draw it as make quick X's with you get 6 of them, but you can take one of those lines and move it over and you get 7. 4, you did what everybody else, what a lot of people did. You just made it 1, 2, 3. You didn't think about overlaps. The answer is 7. It's an ACT question. I was just trying to throw it out there. Those who were trying to be mean to you.
I gave you my answer.
So how do you solve for X? Pythagorean theorem. Now, you will see, ladies and gentlemen, you will see Pythagorean theorem factoring and foiling a boatload of this stuff. So using Pythagorean theorem rather quickly here, you will get something for X. Yes. Excuse me. Shh, guys, come on. X squared is going to be 784. Take the square root of that, and you get now, yesterday, or one of the things I want to remind you guys of, whenever you take a square root over an equal sign, that's always asking yourself, what are two numbers that are the same number? When you multiply them together, you get 784. Well, in this case, it should technically be a positive 28 or a negative 28. Because what's negative 28 times negative 28?
28. I mean, sorry.
It's okay. So you get that positive 784. Now, the reason why we have to get rid of the negative here is because what's the value of X you're looking for? What is that playing the role of in this circle? Can you have a negative radius? No. So the negative value here will not work. Bless you. You okay?
Yeah.
You scared the whatnots out of poor Agli.
Hey, ladies.
Now, again, guys, as you get through this, as we get further in, there will be times when a negative answer can work. So that's why you always stop and ask, does a negative make sense if you take a square root? Here we know the negative won't make sense, so I don't bother with it. Okay? Let's try another one. Did I get out of the sequence again? Nope, I'm all right. Well, let's look at this. Quick review. Quick review of algebra. You will also have quite a bit of these things to worry about as well. When you have binomials multiplying together, x plus 4 times x minus 6, you have to do what? We're FOIL, yeah, distributing FOIL. You're thinking factoring is going backwards. We'll come back. We'll come to this one here later. Okay. So remember, guys, I shouldn't have to talk over you. Okay. Remember, when you're FOILing something out or distributing stuff out, first, outside, inside, last, and you just write it out. You got your x squared. 6x minus 6x and everything that you absolutely loved about algebra comes back again.
I took the car.
Super excited, aren't you?
Wait.
And then you have one last step to do, and that's good old-fashioned combine your like terms. So when you combine your like terms, you get x squared minus the 2x minus the 24. Okay. What's up? All right. It's nothing has changed from algebra. You're just going to see a lot more of this style as we get into circles. Circles are really big. Gentlemen, come on. Come on. What does this mean?
Equation.
Nope, there's no equal sign. Louder. Guys, that's junk squared.
Oh yeah, I remember.
Junk squared is junk times junk. If you just distribute the power, you kill a puppy.
Go ahead.
Ladies,
Can I calculate?
that's not great.
That's my car.
Ladies and gentlemen, this is something that even pre-calc students struggle to remember. When you have what I just call junk squared, that just means junk times junk.
Equals junk.
Good save. So what you're doing here is you always want to write that out twice and distribute. Okay. Distribute out, you get your x squared, 5x, 5x, and then 25. Combine your like terms, you wind up with x squared plus the 10x plus the 25. Now there's a bunch of shortcuts to go through that. If you know them, go for it. It doesn't bother me. I would suggest for the majority of you, since no offense, we do need a little bit of help in our algebra skills from time to time. Just, it's okay. What I would suggest, just write it out. If you write it out twice, then you'll know that you have to FOIL it and go from there. Yes, sir? That's the answer. Because you're not solving for anything. There's no equal sign, so it's not an equation. It's an expression. You're distributing it out to make it to something that's more workable. Okay. Which means then we get to the point of knowing how to FOIL. The next step is remembering how to factor. I know there are so many different ways that people show factoring skills nowadays. I am of the mindset that if we go back to the old-fashioned, I don't mean old-fashioned, but the old tried and true way of knowing some times table stuff, factoring becomes so much easier than trying to figure out the boxes and the algorithmic of the diagonals and all that. It's just, I don't understand any of that. But what I do know to do is this. What times what is positive 40 that I add together to get negative 13?
8 and 5.
I'm looking for what are called factors of 40. 1 times 40, 2 times 20, 4 times 10, 5 times 8, then that's all of it. What combination of those factors, when you manipulate your signs, will give me a positive 40 when I multiply them, but when I add them I get negative. It has to be the 8 and 5. Now, one of the things you should remember, if this one's negative and this one's positive, that means when you multiplied out your terms, they were both negative. Because the last term, your first outside inside last, negative 5 times negative 8 is positive 40. That's where these sign values change from. Okay? So this is an x minus 8 and an x minus 5. That would be the two what are called factors of the x squared minus 13x plus 14. A lot of times I refer to them as what are called terms. Terms are things that we put in parentheses. The zeros are what makes x, or what makes those terms equal to 0. You've done that before as well, and that's one of the other things you will see in this section. If that equals 0, do you guys remember from last year all you did was You'd set both parts equal to 0.
Yeah.
And then you'd say, well, the first one has to be 8 and the other one is 5. And the reason that this works is because of sorry about the bad graph, but when you graph that parabola,
That's what it's called?
yep, that parabola crossed the x-axis at 5 and 8. And you did that last year because you found what are called the zeros. Now, just so you know, next year in Algebra 2, one of the main topics that we talk about throughout first semester is polynomial zeros. Polynomials are quadratics and above. 3rd degree, 4th degree, 5th degree, 6th degree functions that cross the x-axis so many times, and we're going to be able to find those zeros via factoring and other ways, there's shortcuts, believe it or not, and you'll be able to actually, if you know where your zeros are, you'll be able to rough sketch graphs, if I can talk, just knowing zeros and what's called end behavior. So there's a lot of this stuff is all intertwined throughout all classes of math. Factoring and working with zeros is one of them. All right? So why am I showing you all this? So you can do this. This turns into the exact same problem we just did. What's that? Yeah, squint.
No.
What happens again is that we have this this tangent segment. We have this tangent segment that measures 63. It touches the circle at one spot, which means it's perpendicular to a radius. And then we have another radius coming out to another segment that's 49. We need to figure out what the value of x is. This value of x represents the radius within the circle. So if you take the circle out of this, you've done this problem before. You've done this before because what is this value? What is this section here called? It's a hypotenuse, isn't it? This is crossed with a right angle. This hypotenuse is made up of 49 from here to here and x from here to here. So what's the whole thing? 49 plus x. Or can I say it as x plus 49? Yeah, yes sir. No, where's the right angle?
Oh.
Wait, so 49 isn't the whole segment?
Nope.
Oh,
Because
shucks.
remember, I had this back up here. Oops.
I should know. Oh.
That's what I get for trying to redraw it.
Come on now.
This was inside the circle. This 49 part was outside the circle.
Oh, I thought it was 49 just right down below.
So that means the whole thing is x plus 49. So you get your right triangle where you've got a leg that is x, a leg that's 63, and a leg that, or the hypotenuse then is the x plus 49 quantity squared. So you will start to see more of that style algebra. It's nothing more than the Pythagorean theorem that we did earlier this semester. But the reason that you have to chunk it apart is because you've got that radius, then you've got that other part extended after it. Okay? So now you've got junk squared. Remember, junk squared, just rewrite it then as junk times junk. And FOIL it out. I don't know what 63 squared is. Help me out here. It ends in a 9. Okay. Thank you. Take it home. When you FOIL this out, then you got x squared, a 98x, and 2701. I was close. Now, what do you have on both sides of the equal sign? What happens to them? Exactly. They just cancel each other out. You're going to see a lot of this style problem where you wind up foiling stuff out, you're using Pythagorean theorem, you'll wind up with x squareds on both sides of the equal sign. Well, if you go to pick on the little guy with the x squareds, if I move the x squared from the right to the left, I have to subtract it. It goes away. If I move the x squared from the left to the right, I'd have to subtract it. It goes away. Since they have the same coefficient on both sides, sayonara. And now you're in a two-step equation. Oh. What? Yeah, because all you're doing is this. You subtract it over, and it's gone. And now you have 39, 69 is 98x plus 2401. And that's a two-step equation, which all of you can do without a problem. The only thing that was weird is that you had to set it up with Pythagorean theorem and not forget to distribute twice. If you forget to distribute twice, this problem won't work. Yes, sir? Yeah.
So you squared the x. Why is it just supposed to be x plus 63?
No, I'm using Pythagorean theorem. This is
Kevin, you're always touching every stuff.
so subtract out the 2401. I don't have that much more, guys. And if I'm not mistaken, this was 16. Okay. You get 16, then becomes the radius. Okay. Now, I also wanted to make sure that I showed you, I don't know, worst case scenario with big numbers just to scare you. Are you going to see giant big numbers all the time?
Yep.
No, not at all. Okay.
Most anything tricky.
You'll see stuff like this. I don't have that much time. We can kind of go through that here. Same idea. You've got your R for the radius. The tangent segment is 15. The hypotenuse in this case would be how much? 9 plus R. Thank you. Remember, hey guys, you're not multiplying the segments together. It's 9 plus R or R plus 9. Either way is the same. So you'd wind up with R squared, 15 squared, oops, is R plus 9, 180 squared. When you FOIL out the stuff on the right-hand side, remember you're doing it, you're just writing it out twice.
That's a horrible joke.
You wind up with this.
What? What is that?
And you're left with a very quick two-step equation that you just throw in the calculator and be able to set up. Okay? Yeah, give me a sec here. I want to make sure I'm running out of time. Make sure you guys. Now, add these problems to what you had from last night. Let's turn them both in tomorrow. I want you to do the back page. It's 21 through 33. Okay? Do the back page on this one. It's 21 through 33. Please and thank you.
Should we just staple last night's homework to it?
Yeah, oh, I'm sorry. You use a separate sheet of paper because you got a lot of factoring and junk and foiling you on here. Just use these as the problems. You just add them to the sheet of paper you already have. All right, does that make sense? We'll go from there. Yes, sir. What's up? Point of tangency. I said that at the very beginning.
Kevin, you need to knock it off.
All right.
How? Because I said something.
Spares.
Exactly.
The whole back page is B? Or wait, what's the B?
No.
back page?
10.1a.
The other side, all of the other
21
side.
to
You know this?
34.
Which one do you think would be the back page? One page starts at number 1, the other one starts at 21.
You're right. I was just curious. I'm just messing with you.